Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rules in computing a derivative of this given function. Before we can differentiate this given function identified as, again, this is our function, 6 cotangent x plus 4 tangent x. We need to remind ourselves of the appropriate differentiation rules, specifically here for cotangent and tangent x. And take note that our angle here is still on x, but if it's not x, if it's a function, then we also have another rule for that. Let's just take the rule for cotangent and tangent x for the angle, which is x here, to start with our solution. Our goal is to come up with its derivative. But first, let's remind ourselves of the derivative of cotangent x being negative cosecant squared x, and the derivative of tangent x being positive secant squared x. So with that, we are guided on what would be the appropriate differentiation for cotangent and tangent. At the same time, let's review that this is actually on constant multiple, as we have here a constant before our function, same as this. So we simply apply the constant multiple as well. This would mean its derivative will have 6 times the derivative of cotangent x identified here being negative cosecant squared x, and then plus another constant multiple 4, and derivative of tangent x times secant squared x. Hence, the result here is negative 6 cosecant squared x plus positive 4 secant squared x. Now, of course, you can express this as 1 over sine, this as 1 over cosine, but since we can no longer combine them using those identities, let's stick with this, and this would be our final answer for this video. Again, please be guided with the differentiation rules for trigonometric functions, as well as the already proven and provided differentiation rules such as constant, constant multiple, and the rest. Thank you very much for watching. So what are you waiting for? Subscribe now!